AM system, Fig. 4.19, the locally generated carrier has a frequency error 6.W and a phase error O, that is, the receiver carrier is cos, W plus 6.W, T plus 8 or sin, W plus 6.W, T plus 8. Show that the output of the upper receiver branch is M1, T, cos, 6.W, T plus 8, M2, T, sin, A, T plus 8. Instead of M1, T, and the output of the lower receiver branch is M1, T, sin, 6.W, T plus 8 plus M2, T, cos, 6.W, T plus 8. Instead of M2, T, 0.200 amplitude modulations and demodulations. 4.422 A modulating signal M, T, is given by A, M, T, equals cos 100 NT plus 2 cos 300 NT. B, M, T, equals sin I00 NT sin 5007 TT. In each case, I, sketch the spectrum of M, T. 2. Find and sketch the spectrum of the DSBSC signal 2M, T, cos 10007 TT. 3. From the spectrum obtain EDN, 2. Suppress the LSB spectrum to obtain the USB spectrum. 4. Knowing the USB spectrum in, 2. Write the expression plus B, T, for the USB signal. V, repeat, 3, and, 4, to obtain the LSB signal. 4.423 for the signals in prob. 4.422, use EQ. 4.20, to determine the time domain expressions PLSB, T, and PUSB, T, if the carrier frequency W equals 1000. Hint, if M, T, is a sinusoid, its Hilbert transform MH, T, is the sinusoid M, T, phase delayed by, RR/2. Rad. 4.424 find F/LSB, T, and F/USB, T, for the modulating signal M, T, equals NB sin 2, 2 NBT, with B equals 2000 Hz and carrier frequency V equals IO, 000 Hz. Follow these steps. A. Sketch spectra of M, T, and the corresponding DSBSC signal 2M, T, cos wet. B. To find the LSB spectrum, suppress the USB in the DSBSC spectrum found in part A. C. Find the LSB signal PLSB, T, which is the inverse Fourier transform of the LSB spectrum found in part B. Follow a similar procedure to find PUSB, T. 4.425 If MH, T, is the Hilbert transform of M, T, then A. Show that the Hilbert transform of MH, T, is M, T. B. Show also that the energies of M, T, and MH, T, are identical. 4.426 An LSB signal is demodulated coherently, as shown in Fig. P 4.4-6. Unfortunately, because of the transmission delay, T.he received signal carrier is not 2 cos wet as sent, but rather, is 2 cos, W plus 6.W, T plus 8. The local oscillator is still cos wet. Show the following. A. When 8 equals 0, the output Y, T, is the signal M, T, with all its spectral components shifted. Offset, by 6.W. Hint, observe that the output Y, T, is identical to the right-hand side of EQ. 4.20a, with W. Replaced with 6.W. B. When 6.W equals 0, the output is the signal M, T, with phases of all its spectral components shifted by 8. Hint, show that the output spectrum Y, F, equals M, L, D8 4 C colon, 0, and equal to M, J, EJ8. Whenf. C. In each of these cases, explain the nature of distortion. Hint, for part A, demodulation consists of shifting an LSB spectrum to the left and right by W plus 6.W and low-pass filtering the result. For part B, use the expression 4.20b, 4 PLSB, T, multiply it by the local carrier 2 cos, wet plus 8, and low-pass filter the result. Figure P.4.4, 6. Figure P.4.5, 1. PL5B, T. 2 cos, W plus WLL, T plus 0. Low pass. Filter. Y, T. Problems 21. 4.427 A USB signal is generated by using the phase shift method, Fig. 4.17. If the input to the system is MH, T, instead of M, T, what will be the output? Is this signal still an SSB signal with bandwidth equal to that of M, T? Can this signal be demodulated to get back M, T? If so, how?